to talk to you today about was some of the sports projects that we've done over the years, and mostly concentrate on the retractable roof portions of that. So I guess, so as a company, Walter P. Moore, we've been in business for 83 years, out of which only 3 years we've been here in India, and we are learning the market here, and we've started doing some little bit of work here and hope to do a lot of more steel jobs here. We do everything from mid to high-rise buildings, from hotels, hospitals, commercial, residential, and then we also do a lot of steel projects, which I'll share with you in a little bit. But we have 18 offices, 13 in the US, 2 in Canada, 1 in Panama City, and 1 in Pune. In the steel part, we do everything that has the long span structures. That includes obviously airports. We're currently working on 3 international airports. A lot of convention centers. We work on those quite a bit. Performance venues, from performing arts centers, auditoriums, and things of that nature. And most importantly, sports. That's the reason, that's my topic today. So on the sports side, starting in 1950, we have designed over 100 projects. It's probably about 110 projects now. And that includes the very first project, Astrodome. I'm not sure how many of you are familiar with that. In the mid-1950s is when Mr. Walter P. Moore, he got commissioned to do this project. And this is the world's first covered dome stadium. So we've come a long way from that. We've done a lot of open air stadiums, like the Target Field, which has won a lot of awards. We've done a lot of arenas. I would say at least 30 or 40 arenas. I know that there's an arena coming up here in Ahmedabad, so I'm pretty excited about that. The culture of having sports teams and sports stadiums, and that has been slowly increasing in India, and that's very encouraging. We used to be a very cricket-centric country, and now all of a sudden sports like kabaddi and football and everything, and tennis is taking off, so that's very encouraging. I guess I've always been a wannabe sportsman where I was not good at that, so I figured at least I'll help design some of the structures. So this is one of our stadium, Sprint Center arena. We've done a lot of NFL. NFL is national football, and football here is the American football, so pardon me for that. A lot of those stadiums as well. One of them, Invesco Field, about 65 or 70,000 people seating capacity for the Denver Broncos. But most recently, we have been the designers for last 6 of the retractable roof stadiums in the US. Before I get to these, I wanted to try to answer a question: why? I mean, why do we need a retractable roof on a stadium? Right? I mean, there's multiple reasons why. When you pay a high-priced ticket to go see a Wimbledon final or something like that, and you don't want to see this view. There's only 2 umbrellas here. We want to put an umbrella over the entire roof. That's what the concept is. And you want to see Rafael Nadal playing tennis and not just standing around waiting for the rain to stop. So that's one of the main reasons. But as for any other case, money is what governs anything. So there's a money background, and there's a business case for having a retractable roof stadium. The event assurance. So if there's a rain and the biggest event of the year, the final for a tennis match or the football game is going to have to be postponed, then what's the point? There's a lot of loss of revenue there. You can do your stadiums into multi-purpose. So if it's a football stadium, you can use it to have events, some other events like concerts, things like that, something that might need an open roof or a closed roof depending on the type of day. So that's what, in the Indian culture, I'm going to go to a wedding in Pune next month, but they're going to use a stadium to have a wedding. So I mean, so just to generate more revenue, having a closed roof makes sense. Spectator comfort, obviously, I mean, you don't want to go watch a cricket match. I mean, obviously, as Indians, we do spend the whole day there when it's very hot. Rajasthan Royals, for example. So having a roof and an enclosed stadium, that will be good. A competitive advantage. I mean, you'll be able to sell more events than somebody else who doesn't have that. An important part for a lot of football stadiums to have natural grass. You cannot have natural grass if you have a closed roof stadium. So you have to have the ability to able to open the roof and let the grass grow a little bit. And then prestige, I guess that's one of the reasons that we've seen over the world, that just because some other team has a retractable roof stadium, this owner wants to have a retractable roof stadium as well. And that's all right for us, I guess. But if we are thinking that, okay, this is a new concept, to be able to be comfortable, to get sunlight from the shade, I mean, think again. The Colosseum, this is the first retractable roof stadium that was. Obviously, you know, it was a multi-purpose arena. Any architectural element that we can make move. I mean, it could be a wall, roof, anything you can think about. So that's kinetic architecture, and they're one of the leaders in that. They do different types of projects, which I'll touch on a little bit later. So coming back to the retractable roof stadiums. So the first one we did was in 2000, and it was done with the architect Populous, almost 41,000 seat in the ballpark. So this is a baseball field, Minute Maid Stadium. This is in Houston. So I'm not going to spend a lot of time on all 6 of them because I know I don't have that much time. So I'll quickly go through this, but this whole entire roof, it moves and it closes, so it becomes from open to a closed stadium. And there's retractable roof, I mean, you cannot think about it as a fixed roof and it's just on wheels. There's many more complications that have to be designed, construction tolerances, temperature differences. So we'll get into that a little bit. The second one is the Reliance Stadium, again in Houston, and this is the first football retractable roof, American football. And here you can see these 2 big trusses, and they're supported on these super columns. There's only 4 columns and 2 big trusses that support the entire roof. And then there's these 3 elements, that 2 elements, the retractable roof that close it up. Here's a construction shot of that. Here's the super truss. And ironically, this one replaced the first stadium that Mr. Moore designed in the 1950s. So the Astrodome is right next to it. Next one is the University of Phoenix Stadium, where the Arizona Cardinals play in Phoenix. This one, I guess, in one of the presentations earlier, we talked about keeping the structure simple, having a minimalistic approach. This truss, it's a very, very unique design here, and hopefully have some more shots of that. But again, here you'll see a little bit difference here is this roof is a fabric roof because it allows some light to pass through it as well. This is the drum and cable mechanism used to move that roof. It has a very automated system, so basically we are moving this roof at a touch of a button. It takes about 12 to 13-15 minutes to close or open these roofs typically. A unique feature about this stadium is it doesn't only have a retractable roof, it has a retractable field as well. So the whole field where they play football on is a structured thing, and the whole thing can move out of the stadium. So the field moves off the stadium so that they can grow natural grass to play football on. So we have to do a lot of testing with these huge, I don't know if any of you have seen the American football. These are huge guys, 300-pound guys, and when they're all jumping and running around, they shouldn't feel any vibrations. So we have to do a lot of proto testing. The next one is the Lucas Oil Stadium in Indianapolis. This is like a very mid-country, so it has a barn kind of feel to it. And these are the panels that open up both on the sloping sides. And it also has an operable wall which opens up. Again, this has a little bit different drive system because it has to go uphill. I'm going to skip the Cowboys Stadium for now and go to the Marlins, the last one, the Marlins Ballpark. This is in Miami, Florida. The unique thing about this one is the roof all goes on one side. One thing that we do on all these projects is we do a lot of wind tunnel testing, and for the reason that we need to understand the wind pattern, especially being in Miami, there's a chance of hurricanes coming there. So one of the charge given to us was that it has to not allow any air to come into the stadium during a hurricane so that there's no damage. We did a lot of wind tunnel testing, and we did some fluid dynamic testing, and we realized that if we actually, this is the shot from the wind tunnel testing, if we actually keep a little bit of gap in there and let the air come in, we were able to save about 1,000 tons of steel. So that's about $6 million worth of steel that we saved doing that. This is just a shot of the mechanization. You can see the transporter, which is a stiff member here, and then the hurricane ties that hold it down to the and tie it back to the structure. This is a shot of that. Here's the shot of the construction. The next one, the one I saved for last, is the Cowboys Stadium. This one is where the Dallas Cowboys play, and it's obviously in Dallas. And the reason I saved it for last is because this is one of my favorite stadiums. I had got a chance to work on this quite a bit because I was living in Dallas. This stadium sets a lot of records, the five world records basically. First one, it has the longest single span roof structure. So 1,225 feet long arches. That record still stands up, and I think I'm very fortunate to be able to work on this stadium. This is one of the largest dome sports facility with 660,000 square feet. Again, the largest video board display. This thing here, this is 150 feet long. It's huge. And it also has the largest operable glass walls. So this is the overall view of the stadium with these arches that go from this side to the other side. So there's no interior supports on the entire stadium. Well, this picture pretty much speaks for itself, but here's the Statue of Liberty. You can stand up right inside it, and the Empire State Building. That's how long the arches are. This is a section showing that. This is 50 feet below the ground is where the playing surface is in this case. Another section showing there's a lot of box or suite levels in this sector. You see over here, but there's a lot of seating as well, and there's actually 11 elevated levels of concrete seating. Just a quick thing about the schedule, I guess the design took 17 months, the construction took 40 months, and it took 8 million man hours to do the construction, and I only get 20 man minutes to present it, so we're going a little fast. I know we are talking about the steel part here, but just to give you an idea, this is how the concrete construction went. Like I said, there's 11 levels of it. So this can seat 80,000 people at one time, and for a special event like a Super Bowl, it could seat 1 lakh people in this thing. The reason I'm showing this picture is there's a ring beam, a concrete ring beam, which supports roof on one side for this. So this will kind of give you a general idea about the scheme for the roof, where basically we have the 2 arches, then there's 6 box trusses that span in between the arches. These are the 2 retractable panels that open out, and the secondary members that span from the roof to the concrete beams. So just to show the different members, so here's the steel deck. The load from the deck goes to the secondary trusses, then goes to the box trusses, which in turn transfer it to the 2 arches, and the secondary structure, like I said before, these planar trusses, they span from the arch to the concrete ring beam here, which is this member here. This is the model of the bowl, just to give you an idea, and that's the complete model of the structure. So this project had 14,100 tons of steel, and that's about, if you take Boeing 777 and use 97 of those, and then you get 1 Cowboy Stadium to do that. The show rigging allowance, that's another thing from a event standpoint. We can support up to 200,000 pounds of show rigging. This is a concert, so the stadium is now transferred into a concert. I guess it's still, people are still coming in. The arch trusses, we used a grade 65 steel that was imported from Luxembourg. They don't make that in the US still. And the rest of the steel was grade 50 and grade 36. So of course we did wind tunnel testing here, and we got, for each of these little panels, we got a wind pressure with the roof being closed, roof open, walls closed, walls open. So it introduces a lot of different wind load conditions to it, and we get something like that with the high wind loads for a particular case. That's just a sample case. And that brings us to the analysis model. So now you take all those wind conditions, and then that way it gives you 200 total load cases and 550 load combinations to run that model. This we use SAP to design this. There's 14,000 nodes and 30,000 elements in this model. the model, I mean, this is only, we're talking about 3 or 4 years ago, but the computing power was, even with what we have right now, to design the model, we had to run it overnight, right, on 4 or 5 different machines. And next day morning, you find out that you made a mistake, then you again do it the next day. Next day night, wake up 3 o'clock in the middle of the night, hit run again and go back to sleep. So we have to do quite a bit of that. The steel arches itself, like I said, each one of them weighs 325 tons each. And I just threw in this picture to give you an idea. So the 4 chords of the arch trusses, the arch truss was 35 feet deep, 17 feet wide, each one of those. And each one of those at the 4 corners had a member like this, 14 by 730. That 730 means it is 730 pounds per foot. That's the weight of each member. There's 4 of those and then trussed out in between. That's pretty heavy. I'm 150 pounds, so you can imagine how heavy those things are. So on all our projects like this, I think the structural engineer's role is not only in designing and then going away, but I know there's a lot of fabricators here and a lot of steel providers. So we do a lot of design work or erection analysis for our contractors as well. So we design, and you have to do that while you're designing it. If you don't know how it's going to be built, then just designing it in the final condition doesn't really do you much. So we design that. We design each of those trusses. It was like in 57-foot segments or something, and then it was connected by end plates. This picture is showing the arches being built from both sides, and thankfully they met correctly at the center. So that's how the shoring towers were used. And this day, none of the engineering team will forget this day. This is the day when they took off the shoring towers. Even though you know you've designed something correctly, that day you're a little bit nervous, confident but still a little bit nervous. And the deflection that we had designed it for, analytically we had found that it's going to be deflect 15 inches, and that's exactly what it deflected to. It was 14 point something, but pretty close, I would say. So like I said, the integration of the erector early on, that makes a hell lot of a difference. I'm going to talk a little bit about the arch supports. With all this thrust coming down here, this arch support, the pin condition was very critical. So this was basically the pin bearing. If you see there's 1, 2, 3, 4 elements going on. That was a casted element. It's cast in Michigan, milled in Massachusetts, and then brought in Texas. It's 64,000 pounds each. So it had to be perfect for it to be a pin element. Then we had to obviously put it on the field itself, and it was supported on this thing which we were calling the abutment, and then obviously a lot of anchor bolts connecting it to the abutment. This is an interesting picture. This is what's above the ground, and this is where that steel pin that we saw is going to go. This is the abutment. Looks like it's steel, but it's concrete. It's just 1% reinforcement, but to get the idea of how big it is, you'll see there's an iron worker over here. There's one guy over here. So this is huge because it has to support 19 million pounds of thrust over here. So what you are seeing above the ground was this part here, but below the ground we are resisting all that in friction. And this thing is 170 feet long and 71 feet deep, with 2 walls of those at 18 feet in center. So it was a huge reaction. Talking a little bit about the retractable roof models. Again, these are the retractable pieces that come and park over here. This is shot from the inside, shot from the outside, and it's lifted up. But this is how we designed it. So on one side, this is like a section cutting through the retractable roof section. One side it's fixed, on another side it has the 4-bar linkage. So when there's any lateral movement due to change in temperature conditions or some misalignment in the rail or anything happens, it shouldn't damage the rails or the operation of the thing. So that's why it lets this move, and I think I have another way to explain that. But then this part, if you take a look at this, I mean, this is the main transporter frame, which is a rigid. This is the 4-bar linkage over here, and these are the electric motors. There are only 7.5 horsepower motors, 64 of those for each one. So it doesn't take a lot of horsepower to move these things. This is another shot of that and the actual picture. So I'm just going to show you a few more construction photos of that, just because I like it. Go through that real quick. And this is a nice view. This is the two glass walls that are opened up, and you can see the entire stadium. People can stand outside, inside, mingle. So it's a huge structure. And this is an interior shot again. All right, so on this 6 projects that I just talked about, there's a lot of lessons that we have learned, and we captured those because there's a lot of things that have gone wrong in previous projects, not designed by us, but I'll show you some examples. So I think one thing we have to understand is retractables are more complicated than just roofs on roller skates. So that's not what it is, because there's a lot of the design and thing has to be, it's twice to 10 times higher than the static structure, what the complexity of these things are. And there's strong evidence of track record of the wrong thing. I mean, these are other retractable roof stadiums, there's some of them in Europe, some in Japan, this one is in the US, which haven't worked well. So if you're spending so much money and if they don't work well and they don't open when you're supposed to open them, then the owner is not going to be very happy. For example, a lot of you know about the Wembley roof. I mean, it also has a retractable roof, but from about, it used to take 10 minutes to open it, now it takes 56 minutes to open it. So that's why having the integration of a good mechanical consultant who knows about and can understand the small details about moving something, and working with a structural engineer who can work with that is very, very important. So simple thing, I mean, if there's a high point in the roof, I mean, these are not Swiss watches we are doing. These are big stadiums, so there's going to be construction tolerance issues. Then it has to have some flexibility for it to move. So and different roofs will have to come up with a different solution, because not all of them like other buildings are made equal. So this one shows how the 4-bar linkage that I showed in the Cowboy Stadium, if there's movement in this direction, then it doesn't put a big load on this rail over here and can still manage to move the roof properly. Another technique that we've used is over here with a linear bearing on the side. On the Minute Maid part, you can see that there's a hydraulic damper here. This is a released hinge and the fixed is over here. So there's different mechanisms that we've used to make this work correctly. Again, a similar thing for this one. This is the linear bearing that I was telling you about. So this was on the University of Phoenix Stadium. Third lesson, and most important, this is not only for retractable roof stadiums or stadiums. I guess economy comes from simplicity and a holistic approach. That's true for any project, but more so over for here. You have to be able to use load paths and things that are very simple, not try to make things unnecessarily complicated. Use of proven and reliable parts, that's very important. And if you're not using something that's been proven, then you have to figure out, okay, how you're going to do the maintenance part of it. You have to look at these as long-term buildings, like we were discussing with somebody earlier. These are not projects that will go away in 10 years, 20 years, or something like that. Erection planning is important, like I told you guys earlier. And the design has to be fail-safe. You always have to think about what if, because especially in this field, there have been some failures. And by failures, I don't mean something has collapsed. But if a retractable roof doesn't retract, I think that's a failure. So if there's parts that you haven't done before, we do a lot of prototype and testing for the life cycle of the project. That I think is very important to make sure that it will act in the way that you think it is going to act. It's a continuity of responsibility. You cannot just design it and walk away. In doing the parts, in actually getting the right parts, milling it, making sure that it's done correctly, that is the responsibility of every structural engineer. And we have to be in a design assist role. We cannot just walk away from the problem. And the recipe for success is a well-structured process. We cannot do this we have to understand the challenge. It's going to be different for each project. The right team has to be there, agree on the goals, make sure that the owner and the client knows what he's getting into, and use a structured process to manage the risk and take a holistic approach. So you guys must be thinking, great. I mean, that's all good. Thank you for showing us that. But probably none of that is applicable in India, is probably what I'm sure you guys are thinking. And I've thought about that as well. But that's actually not right. I mean, retractable roofs, we have to think about it as a kinetic architecture. There are many applications for this. We're not talking about just the roof. Even for the cricket stadiums, we actually can do that. Like we've done in a lot of football stadiums, there's a lot of different fabrics available. Like anything else, the technology is evolving. Fabric that can cover the whole roof, which can basically can be shrunk down in a very small area, that can be suspended from the center of the roof or from one side and the cantilever, and then the whole roof can be covered. So there are many things we can do that. But you can also think small. I mean, if like a mall structure or some other event place where there can be an operable roof. This is a mall, by the way. So this doesn't have to be there. It could be on a terminal, airport terminal building or something like that, where we can, at different times of the day, you can have something open or closed depending on what elements you want to let in versus what you don't want to let in. You can use it as a shade, which actually rotates depending on the time of the day and encloses your building, so you can protect it from the sunlight and you don't have to spend as much, especially on net zero buildings. This is a very good application, something that has something similar that has already been done. Talking to one of the architects here in India, and he was saying, okay, can you actually do a retractable flat? I said, maybe not the whole flat, but if you want to have a living room that just pops out of, if you're going to have a party at your luxurious building that you're going to do, and then if you want to make something special, you can have the whole living room kind of cantilever out, and then you can have a party right there. So in kinetic architecture, I think the options are unlimited. It's just our imagination that we just need to run wild with it. And that's about all I have. Thank you very much.